All right, so obviously these are all super important because otherwise, why would I ask them every single day? I'm going to start with, well, I don't want you guys to start with a product. If it asks for the product of two numbers, what do you know you're going to be doing, Brayden? Multiplication. How about if they ask for the sum? Colton? Addition. And if they ask for the quotient, Jillian? Divide. You're going to be dividing. And what's a variable? Oh, it's amazing how some hands drop on that one. Madison, what's a variable? Yeah, it's a letter in like a number sentence. And do we always know what that letter is? No. Sometimes we have to use the other clues they give us or some of that algebra, right? Like we do the opposite to figure out what that letter might mean. How about, I think all we have is, what's the difference? Connor? You know it's going to be subtraction. How about, what's a rate? If I say, oh, the rate of this is blah, blah, blah. What am I talking about? What's clear? Miles per hour is an example of rate. How many kind of things are in a rate? 1, 2, 3, 6? 2, right? There's two things that they are in context together. And what words do you typically see in a rate? Per, right? So like miles per hour or dollars per pound or...
Just think of your cat.
There you go. Okay. One you might have heard, or you've seen a lot of them. We just might not have been calling them this so far. Algebraic expression. What does algebraic kind of sound like? Algebra, right? We do algebra when we do these. And so really, algebraic expression is just yet another kind of name they use for number sentences or what's something else? An expression, I think they've called it. It's all kind of meaning the same thing. And an example of it is 2j plus 3 equals m. Okay, and they might give you that and then say, find what m equals when j equals 4. Okay, so then you know instead of that j, we can put in a 4 to figure out what m equals. Flashback? You're like, been there, done that? Know what? Bracket? Alright. Before I give you this, yes, I know it is the same worksheet on both sides. Okay, so whether you're on this side or this side, it's this page. I was trying to save the planet and do worksheets two-sided, and I must have scanned the same worksheet twice. Okay, there's the Monday. So yeah, I want, but I want you guys to be able to have it.
Maybe we need to take another nap.
It's just been kind of a off morning. Oh, stop. What are we talking about? That's right, apparently they're not.
You're not a failure.
We learn from our mistakes, right? Oh, I'm sorry.
No, this is right. The mode was 2. 19 pounds.
Okay, so apparently I did make the worksheets correctly, but I want you on this side. You ready? Okay, so sometimes, as we've seen, they don't give you the rule. We have to kind of figure it out. Okay? One of the easiest ways to do this, if they give you a graph and say, okay, what's the rule for this graph, is to find points on that line graph and put them into your table so you can, it's easier to notice a pattern in a table than it is on the graph. So graph A is this one. Oh, you guys, now my smartboard. It's just the red one. Okay, it's just the red one. Okay, this is graph A. Do you see some of the kind of the little dots?
Yeah.
On graph A?
It's a little better on our case.
Yeah, it turns out a little bit better. What are some of those points? Let's start down here. What is this point? Remember, X is always this one.
-4.
-4, -3. What's another one?
-3,
And I think there's 2 more on this graph. Can you see them?
0 and -1. 0, -1. It looks like negative.
But is it above the 0 or below the 0? It's just 1, yep. And what's in the last one?
2, 3.
2, 3. Okay, so we are looking for a rule that every single time when we go from X to Y, the same thing is happening. What is happening every single time when we go from X to Y? They're adding one. They're adding 1 to what?
Add 1 to. Adding 1 to X.
To X, right? Because if you added 1 to Y, that doesn't work. Okay? So you'll have your X, you add 1, and that's going to give you what?
5.
Y. What did I just write? What is that an example of?
Algebra expression.
An algebraic expression, right? Because to figure it out, we'd have to use some algebra. Was it? Okay. Does anybody have any questions on how I got the table and how I used the table to find a graph?
No.
We feel okay?
Yeah.
I don't think we've done anything exactly like this yet, but we've kind of done something like it to kind of put together.
Okay.
Okay, let's look at graph B. Okay. That's that one. What are some of the points on graph B?
4.5 and 4.5.
4.5. Good job. I know that one was a little bit trickier. It wasn't exactly on a nice stretch. The next one's a little bit easier. Where's the next one at?
4.1.
Is that one above 0 or below 0?
Negative.
If it's above 0, it's positive, right? So what is it? Is it positive or negative?
Positive.
The world may never know.
It shows it's above the 0. It's on the top half of the y-axis.
So we're looking at
The row right on the top.
this one.
Yeah.
Okay, 0's right here. So is it positive or negative?
Positive.
Positive. It's above that 0. And the next one is over 2, 3.
And then negative 3 and 8.
Yep. Negative 3 and 8.
Who's confusing?
Huh. This one is kind of tricky.
I am confused.
This one is kind of tricky. I don't know if we've seen one like this. Here's my hint. Look at the X and the Y together. Do you notice a pattern when you put them together? It always equals what?
5.
5, right? So
Wait, how's negative
4.5, 4.5. What are we doing to get 5?
X plus Y equals.
So if you take your X and you add what?
X plus Y.
What do you get every single time when you take X plus Y?
Your total number of it. Or you get 5.
You get 5 every single time.
That's pretty cool. That's
That was one. I won't give you one like that on the test, but because yeah, that one's different than the ones we've seen. But I also wanted you to see that it's not always going to be X plus 1 or X minus 2. Sometimes the algebraic equations are a little funky. Okay, how about graph C? The last one we haven't done yet. What's a point on that graph?
a 5, negative 5.
Negative 5 and 5.
Which one comes first?
5.
5.
5, negative 5.
And then it was down 5. What's another one? 3 and negative 3.
And then negative 1 and 1.
Yep, so it's the left one and up 1. And how about that last one?
Negative 1.
Negative 4.
Well, this is kind of like the other one.
This is kind of like the last one a little bit.
Just opposite.
But how would you can't really write that in an algebraic equation. You can't say flip them.
You could put X plus Y equals 0 because it does.
Patrick, you had that one. Right? So if you tell me that every time you take X and you add whatever's in the Y, what are you going to get every single time? 0. Okay, any questions? Feeling okay? Okay. Now you guys are like falling asleep. Okay. Ooh, this is a good one to practice.
Are we doing it together?
Yeah.
Yeah.
Okay. I will tell you right now, there are questions just like this on your test. Okay? So if at any point you're like, I have no clue what's going on, and so confused, make sure you ask questions. If you don't know it now, you're not going to know it on the test.
Wait, are we taking this home or are we going to the back side?
I don't know, it depends how far we get.
I'll pull it off and throw it in the garbage.
Make sure to hurry those people.
I'm sorry, I want to leave. I can read the song.
Okay. So, sometimes they don't give you all the information, right? They like to make a puzzle out of it. So they gave us these 5 graphs up top, A, B, C, D, and E. Okay? They told us that the bottom label is all time. It's all talking about something over time. But we don't know what. We have to figure it out. Okay? These are kind of like those problems I told you about that really you kind of just have to use your common sense. You have to figure out what makes sense in the story. So in the first one it says, a frozen dinner is removed from the freezer. It's heated in a microwave oven. Then it's placed on the table. Okay? So which of those graphs do you think can match? So you think about, what would the Y label be in this case? If it's talking about time on the bottom, a microwave dinner, you take it out of the freezer, you put it in the microwave. What do you think the Y label would be? Probably the temperature, right? So one of these is talking about, okay, as time goes on, this is happening to the temperature. Is it going up? Is it going down? Okay, so let's think about it. If you were to take a frozen dinner out of the oven, where do you think the temperature is going to be at? Do you think it's going to be like a really hot meal, kind of in the middle, or do you think it's going to be kind of like down at the bottom of the graph? Probably the bottom of the graph, right? Because if your temperature is way down, it's going to start low. Okay?
You can see it's only when it goes underneath the graph.
Okay, so let's think about this with the situation. Does this make sense? So it's taken out of the freezer, it's pretty low, it heats up in the microwave, and then does it make sense that if you placed it on the oven, the temperature would kind of stay the same? It might go down a little bit.
Yeah, because it's cooling.
Yeah, it's probably cooling a little bit. Is it going to drop super fast as soon as you take it out of the oven? Probably not. So I would agree that graph C would match that situation. Okay, you don't have to draw a picture if you just write C. That's fine.
It already says.
Oh, yeah.
This one has multiple steps on it.
Okay. Let's look at the next one. It says, Sastia runs water into his bathtub. He steps into the tub, sits down, and then bathes. Then he gets out of the tub and drains the water. So which one do you think might kind of fit what's happening? So he runs the water, he steps in the tub, he sits down, he bathes, and then he gets out of the tub and drains the water.
Probably A, there are multiple steps in it.
Here's some B. So it says, which graph shows the height of the water in the bathtub? So if we look at graph B, this is saying, okay, so he runs the water's running.
This is at different times.
So yeah, so those of you that initially thought B, what this is saying is that the water's running, the water's getting higher, the water all goes away. Is that what our story told us happened? No. However, some of you were shouting out A. Okay, so the bath is filling up, right? The height of the water is going up. Okay, the water's kind of sitting there. It's probably getting ready to bath. He steps in. So what happens when you step in a bathtub of water?
It splashes water.
The water gets a little bit higher, right? What happens when you sit down in it?
It gets higher.
It gets even higher. What does this straight line mean? What's that part of the story?
It's just sitting still.
It's just sitting there, because what is he doing at that part in the story? He's bathing, right? He's not like sitting down, standing up. He's just sitting in the bath, still bathing. But then he stands up, he steps out, and then what do you think this part means? The water's draining, right? It's not going to just drop off to zero, because when you pull the bath plug, does it automatically just all go down in a second? No, it takes a little bit of time, so it has to come down a little bit. How we feeling so far with these? Okay. You just kind of gotta, these are ones especially you can't rush. You gotta take a second and think through.
Next one, I think it's
Okay. So in this situation, a baseball is thrown straight up in the air. Which graph shows the height of the ball from the time it's thrown to the time it hits the ground?
I think it's B. B or D. B or D.
It's probably B because they're saying it's going up. When does it go up?
Okay, so some people say it's B, some people say it.
How is it D? Because the ball has to go down. The ball comes down though.
Ooh, I'm sorry. Okay, so D, if we look at D, okay, right, the ball probably would start about here, right? Because you're not going to like go all the way down to the ground to throw a ball up, right? You're probably standing there, so the ball's already a little bit off the ground. And if you throw it, it gets higher and higher and higher and higher.
But it doesn't show that.
And then it stays up
down.
there.
No.
Is that what happens?
No.
No. But if we look at B, right, it kind of starts, it's not starting all the way down to the ground, it's starting a little bit higher. You throw it up and it gets higher and higher and higher, and then it kind of reaches its point and then drops all the way down to the ground.
But he never said it came down.
It did. It
The
said
laws of gravity.
from the time it's thrown until it hits the ground. Yep, that's what we do.
I don't think it has to say that because it's the laws of gravity.
What if we went into space?
Strong first.
Okay, so this is still the same situation. A ball is thrown straight up into the air, but this time it wants us to find a graph that shows the speed of the ball at different times. So think about when you throw a ball. When is it going the fastest?
When you first know it.
When you first throw it, right? When you use all your muscles and you just let go. When is it probably going the slowest?
When it's at the top. When it's dropping. When it's
Think about you throw a ball up in the air.
when it's at its highest point.
When it's at its highest point, right? Because it kind of like soars at the same height, and then when it starts to fall, it goes way faster. So I think so far we have D and E left. So which of those shows that it's going the fastest at first, and then it kind of slows down, and then as it falls, it goes faster? D, right? So you're throwing it, it's slowing. That's E. What did
You said D.
what did you guys say?
D.
I said B.
Okay, well then let's start with D. Okay, we throw it. It's going faster,
Slow.
faster, 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 faster. Forever.
It's E.
Not so much, right?
How would you do that though? Like if you
I'm gonna explain it. But this is talking about the speed. This isn't showing the path that the ball is traveling. Okay? So in this case, if this is the speed, it's going the fastest right when you throw it, right? We said? The farther it's in the air, it's slowing down a little bit, slowing down a little bit. It's at its highest point, and it's not really going anywhere. But then as it drops, it goes fast again. Okay? So don't think of this in terms of like, oh, when I throw the ball, I'm throwing it down and up and down. Because it's not talking about where the ball is. Okay, that was more this one, right? Where it was, how far it was. This one is talking about its speed. Okay, does that one make sense? I know that one was probably the trickiest one.
A little bit. It's not hot.
Okay, so yes, that is E. Where are we at? Okay. Okay, one thing I wanted to show you. So algebraic expressions, most of the time, it will give you an equation, or a number sentence, or an expression, whatever you want to call it, and then it'll give you what one of those variables is worth, right? It'll say when k is equal to 2, or when b equals 4, and you have to figure it out, okay? However, there is one little trick to that one, okay? sometimes they have a number right next to a parentheses. Okay? Before you can put a number in for the variable, you have to do something else to the equation. Okay? It is called the distributive property. And you can think of when you distribute things. When you distribute Valentine's Day candy, what are you doing? Kind of giving it out and spreading it around. So we have to, I like to call it, we have to spread the love. Okay? Because that 2 has to share its love because that 2 is right next to a parenthesis. So, the 2 has to spread the love to the x and to the 1. And that 2 is going to spread the love by multiplying. So if you take x and you multiply it by 2, what do you have now?
We don't know. It could
2x, right? Instead of just 1x, you have 2x.
That'll be 2 times.
Okay? Our sign still stays the same. Okay? But 1 needs to feel the love too. If you have 1 and you multiply it times 2, you have 2. Does that 3 get to feel the love too?
No.
What issues are we having? I'm up here. Landon's not teaching. I'm sorry, does the 3 get to feel the love?
no.
How come?
Because it's going to be added. It's going to add from your answer to that problem.
You're right, but why did we spread the love to the x and the 1?
Because you're under the parentheses.
It was in the parentheses. Is that 3 inside the parentheses?
No.
No. So this just has to stay the same. Figure this out for me. You can do it just on the back side of that worksheet we just did. If I told you when x equals
3 and 5. 12. 7.
4. So tell me what this algebraic expression comes out to be. What's the final answer when x equals 4?
Actually, it would be 5 plus 24. I know it's 3 though, 5 minus 24. Adding's first. This is.
Kevin does.
Forgot that. I don't know.
Okay, remember when I tell you to rewrite it, you won't make silly mistakes if you rewrite it. So what does that mean when a number is right next to the variable?
It means you multiply.
You know you're going to multiply. I know what x is. What is x? 4.
8.
2 times 4 is?
8.
Okay, I kept everything the same. I did 1 step, and then I kept going. So now I have 8 minus 2 is?
6.
6. And I have this left. 6 plus 3 is?
9.
Did you get 9 when you tried this on your own?
Yeah.
Good, I hope. If not, don't worry, we're going to do more. Okay. So we have 6 times p plus 6 plus 6 is also equal to which expression? So we have to spread the love. Okay, we can't leave that poor 6 kind of like on the outskirts of the parentheses all on its own. So what are we going to do first? Before I can tell you what p equals, we have to spread the love. We are going to spread the love to the p and the 6. Are we going to spread the love to the 6 too?
No, it's not in parentheses.
It's not in the parentheses. We can't spread the love to those not near us. Okay? So if I have p and I times it by 6, what am I left with?
You left it.
I have 6 of those p's now, right?
Yeah.
if I have 6, and I spread the love 6 times,
You get 36.
I am left with 36. Okay, don't forget that part on the outside though. We're not spreading the love to it, but we're also not just forgetting about it. Okay? Let's say when I say P is equal to
Pennies.
2. Figure this out on your piece of paper. So write it out again. And this is no longer P because we know what P is equal to. And I'll give you a minute so you have a chance to think.
I think I got it.
That's okay, we're gonna go over it. I'm glad you tried it though, I know. Okay, I know what P is. What is P?
2.
2. So I can take that P out. But what am I doing? If that number was right next to that letter, what am I going to be doing to them? Am I going to be adding them, subtracting them?
Times.
Multiplying, right?
Yeah.
Because they're right next to each other. So we start 6 times 2 is
12.
12. The rest all stays the same. 12 plus 36 is
48.
48. The only part I haven't done is this last plus 6. 48 plus 6 is
54.
54.
I think everybody was about to say 52.
Say thumbs up if you rock that. You got this. You're feeling great. To the side if you're like, oh, I'm almost there. Thumbs down if you're not listening. Okay. Let's see. I think I might have one more. Ooh. Okay. So I have 3 times 2 minus E plus 3 plus 1. What do I have to do first before I can tell you, oh, E is equal to whatever? I have to share the love. What am I going to share this love with?
The 3, the E, and the 2.
So I got to spread it to the 2, to the E, to the 3. How about to the 1?
No.
No,
We hate that one.
that one is not, you can't spread love to someone that's like way over there. Okay? So this 2 is going to become what? 6, right? Because you're spreading the love 3 times. What happens to my subtraction sign? Keep it the same. I can't change what I'm doing to the problem. I just have to spread the love. What does that E become?
3E.
It becomes 3 because you're spreading the love 3 times. What does this 3 become?
9.
9. My symbol stays the same. What happens to that 1?
You add it still.
Do I change it at all?
No.
Nope, because I can't spread the love. Let's do when E is equal to 2. Try it. Okay, this is no longer just E. It's not a variable anymore. It's what?
2.
2. What am I doing to the 3 and the 2? Am I adding them, subtracting them?
Multiply.
Multiplying, because it was a number right next to a letter.
So 3 times 2 equals 6.
According to PEMDAS, do I start with the subtraction?
No.
No, remember, parentheses, we don't have any. Exponents, we don't have any. Multiplication and division? Yep, we had that. So 3 times 2 is 6. The rest of this stays the same. Remember I said rewrite it every time?
We should go back to that triangle. It's not a 6 is 0 plus 9 is 9 plus 1.
Okay. So now we don't have any division, so we can move on to addition and subtraction. According to PEMDAS, if all we have left is addition and subtraction, where do we start?
Beginning.
Just right at the beginning, yep. So 6 minus 6 is 0. I keep the rest the same. 0 plus 9 is
9.
This is like a whatever you call it.
10.
It is, right?
I just did.
Oh, that's what you're talking about. And 9 plus 1 is
10.
remember every time we did PEMDAS, what did we call it? The triangle of success? Right, didn't we call it like the triangle of awesomeness or success or whatever?
Triangle of man.
Whatever it came out. Right? If you are in Mr. Anderson or Mr. Oskey's group, you can grab your stuff and go where you need to go. The rest of us, I think I have. Ooh,
That's hard.
this is a good one.
I got it. They're the same. 16 is true. It's not the same. That is. This is true. I know it is. That's what I said.
Hey, what's the easiest way to figure out if this is true or false?
Do parentheses first.
So just do it, right?
Do one problem.
According to PEMDAS, you have to do the parentheses first. So 4 times 2 is?
8 times 2 is 16.
Okay, so this side comes out to be 16. If we do the parentheses first over here,
4
4
times 4 is 16.
is 16 equal to 16?
Yes.
It is true. Okay? I can promise you, you're going to see one just like this on the test. So if you're confused on how we got here, make sure you ask.
That one was poor listen.
Okay? Try this one.
Ooh. 8 divided by.
Don't say the answer, try it on your own.
Can we do that on our best? 9 divided by.
No.
No. What the heck?
Everybody needs to do it because everybody's going to have an answer. Oh. Whether you think it's true or false. Right? All you really need to figure out is if this is equal to the exact same thing as this. I'll give you about 30 more seconds.
Even when it's not a division, I still try to get it managed.
Yeah, I believe.
That's false. She just said
Okay, if you think this answer is true, you're like, yep, they equal the exact same thing, I want you to go stand over there. If you're like, nope, they do not equal the same thing, it is false, I want you to stand over there. That's why I said every single person needed an answer. Yeah, you need to pick a side. That side's true, this side's false. Wow, everybody has the same answer. Do you think you're all right or all wrong?
All right.
I think you're all right. Go ahead, Chelsea. Gentlemen, quickly, otherwise you can't do these things. Okay? Because 17 minus 9 is what? 8. 8 divided by 4 is 2. Okay? this came out to be a wonky answer, but you knew that it wasn't 2, right? Because you have to start with the parentheses. 9 divided by 4 is,
Like 2 point something.
yeah, like maybe, if you're going to estimate, maybe just like 2.2. Okay? But if you take 17 minus about 2, are you going to get 2 for answer?
No.
No. So even though you didn't figure out exactly what this side equals, you knew they weren't the same. Okay? Feeling okay?
Yeah.
Feeling fresh? Feeling great?
That one's a little more.
That was a little more complicated, but everybody got the right answer, so everybody got there.
Some people just put out with it.
Okay, so here's what we're gonna do. To give you a heads up, probably not tomorrow because like I said with the 2-hour late start, I'm not sure that we'll have time for math.
But usually we do.
We'll see. Okay? However, if we don't get to the next 2 slides tomorrow, we will finish them up super quick on Wednesday, review Wednesday and Thursday, and then test on Friday. Because right now, I feel like you guys have taken in about all you can take in for today.
Yes.
Okay? And I feel you. I don't want to overwhelm you.
Especially since none of us have slept.
So, we will finish what we didn't get done over the next 2 days.
We don't have to
Okay? So, for the last about 25 minutes,
How many questions